Assalamualaikum everyone. Welcome to our second virtual lecture. This time it is on topic 2, describing data. And as usual, I hope you will use these slides together with your lecture notes as well as your required textbook. Before we begin, I'd like you to take note that due to time constraint, we will only be covering the numerical measures of describing data. So if you take your lecture notes with you, if you look at pages 4 to 7, we will not be covering them because I'm assuming that you have covered these topics at the Center for Foundation Studies, or CFS. So we will only be studying page 8 onwards. So page 8 is basically the numerical measures of describing data, and this will be covering the following topics: central tendency, dispersion. These two will be covered in this video, and then when I meet you again in class, we will look at the usefulness or the applications of the mean and standard deviation, as well as describing the relationship between two variables. When we want to describe our data numerically, there are basically two things that we want to talk about. The first is our data's central tendency, and second is our data's dispersion. Now let's look at central tendency first. What is central tendency? Central tendency basically tells us about the center of our data set. In other words, we want to see where do all of our data tends to concentrate at. So if you want to know what our central tendency is, we need to use several measures. Now we will learn 3 different measures of central tendency: the mean, the median, and the mode. Let's look at the mean first. So mean here basically means the average value of our data set. And compared to the other measures of central tendency, the mean is the most popular or most widely used measure. So here I have shared with you the characteristics of the mean. Now before we go into the characteristics, please bear in mind that if you want to calculate the mean or average value of your data set, you have to make sure that your data has at least an interval scale. Do you remember what interval scale is? If you don't, please pause this video and go back to topic 1. There I have taught you about the different levels of measurement. So I repeat, you must make sure your data set has at least an interval scale. Then only it is possible to calculate its mean. Now let's look at the first characteristic. When we want to calculate the mean, we will be using all the values. Now this is a good thing because you will soon enough discover that it is actually quite difficult to collect data. When you start your assignment, you will know that. So obviously you don't want to waste even one number. You want to be able to use all of the values, all of the numbers that you have collected. So in that sense, the mean uses all of the values. So this is a good thing. Secondly, the mean is unique. What it means by unique here is for every different data set, you will have different means. For instance, we have 2 sections in this class, section 5 and section 6. So although you will be doing the same quizzes or tests, the average or the mean for section 5, when I calculate, it will be different than from section 6 mean. So that is what it means the mean is unique. Now the third characteristic, the sum of deviations of each value from the mean is 0. Now here I will try to draw something here, so hopefully it'll be clearer. Let's say you have a number line, where there are 5 numbers: 1, 2, 3, 4, and 5. I do apologize if it doesn't look nice, but bear with me lah. So now we've got 5 numbers here, and so you can see where's the center. Remember, what is central tendency? Where is the center of our data set? So in this case, let's say these 5 numbers are our data set. So where's the center? Yes, 3. So this is our center. Now let's try to find the deviation. Another name of deviation, it means difference. Let's find the difference of each value from the center. So what are our other values? 1, 2, 3, 4, 5. So what's the difference between 1 and 3? 1 and 3, the difference is -2, right? What's the difference between 2 and 3? Yes, -1. What about 3? Remember, 3 is not just the center. 3 is also a value. So the difference between 3 and 3 is 0. There's no difference lah. What about here? Difference between 3 and 4. Is there any difference between 3 and 4? Yes, 1. Now the difference between 3 and 5 is 2. So what we want to find here is the sum. See, the sum of deviations of each value from the mean. So I repeat again in hopefully simpler terms, the sum or the total of all of these differences of each value in our data set from the mean. So add them all up. -2 plus -1 plus 0 plus 1 plus 2. What you'll get? You will get 0. Okay, so this is what this characteristic means. And I tell you, this characteristic is the most important, and you will find its importance later when we study dispersion. Okay, I'm going to erase this now so that you can view the other notes. Okay, hold on, give me a second. Okay, let me just erase everything. All right, so I hope you understand the characteristics of the mean. Feel free to read the textbook to learn more about them. Now, so far what I've shared with you are the advantages of the mean. Of course, nothing is perfect. We also have disadvantages. Here, one very important drawback of the mean is that it is very, very sensitive to outliers. Outliers are basically very big numbers or very, very small numbers in our data set. So let's say you already have the mean here. Okay, but if you have outliers, the mean will be disrupted. The mean will either be pulled towards that big number or pulled towards the small number. So in other case, so what it means is sometimes the mean may not be a good representation for your data set, and that is why we have all of these other alternative measures of central tendency. Okay, now let's move on. How to calculate the mean? Okay, so well, it actually depends on what mean you want to find, whether you want to find the population mean or the sample mean. Again, if you don't know or can't remember what's the difference between population and sample, please pause or stop this video, go back to topic 1. I have already explained the difference between population and sample. Okay, so this is the formula for population mean, the one up here. Okay, and this is the formula for sample mean. This is our legend. So hopefully you know what each item means. Okay, here, up here, okay, if you notice they look the same. Well, it simply means the sum of values. Okay, you don't just have one value in your data set. You might have 10, 20, 100, 30, whatever. So you have x1, x2, x3, and so on and so forth. So the sign up here, this one, it means sum. Okay, so it's basically the sum of all the values in your population or sum of all values in your sample. All right. Okay, so that's the first legend. And then what else? N, the capital N refers to population size, obviously, because if you want to find population mean, obviously you need to divide the total sum of all values with your population size. If you want to find your sample mean, you just divide all of the sum of the values with your sample size. So this is your population mean. We pronounce it as mu, mu. X bar here refers to our sample mean. So please know what you want to find. Are you finding your population mean or are you finding your sample mean? Now let's look at the first example for mean. If you turn to page 8 of your lecture notes, example 5 is there. Now ideally, I would like you to attempt this example first before looking at the answers, because by just knowing the answers, it will not help you, or it will not help you understand. Okay, so if you can, please pause the video right now so you can try out the question first. Right, so if you have already attempted it, let's read the question. We see here we have this company, VATS. Okay, VATS customer service counts all the number of incoming calls per day during the first 7 days in May. So they ask you to compute or calculate the mean, and then they also ask you, is this a statistic or is it a parameter? Now remember guys, if you don't know what a statistic or a parameter is, please pause the video, stop the video, go back to topic 1. I have already taught you what's the difference between a parameter and a statistic. Okay, so go check that out. All right, so this is the first part of the question. So they want you to calculate the mean first. First of all, is this a sample or is it a population? What do you think? Okay, so the answer is actually in the clue up here in the, it's already mentioned here. So they tell you that the following is all, keyword, all of the incoming calls during the first 7 days in May. So the keyword here is all. If you remember, what is population again? Is the collection of all items or people or whatever that is of interest. Okay, so yes, we are actually finding the population mean. So you know that if you're finding population mean, it's actually a parameter. Okay, so anyway, let's do the calculation. Let's show here. See, so you need to find mu. Okay, so remember, why are we finding mu? Because we are finding the population mean. How do you know it's a population? Because of this word, keyword, all. Okay, so how to find the mu? If you recall the formula in the previous slide, sum of all of the values in your population divided by the population size. So yeah, you take all of this data, you add them all up here. Okay, please don't do this dot dot dot. Okay, I do this because it's just the slides. I want to fit it all into one page or one slide. You guys, for exam purposes, please write in full. Okay, so you add all of the values of x, divide by your population size. So what do you get? Yes, you will get 23.9. So that's your answer. This is your population mean. So is this a statistic or a parameter, as I mentioned to you just now? Because this is a population, therefore this is a parameter, because it includes all of the calls during the first 7 days in May. Okay, the second part. Giant Hypermarket began a study of overtime hours among its workers. A sample of 15 workers showed the following overtime hours last month. So the keyword is there, sample. So are you finding or are you computing the population mean or sample mean? Yes, you're finding the sample mean. So write down, you're finding the sample mean, or we put it as x bar. Again, you need to add all of the values in your sample, see up here, which are all of these values. Add all of these values and divide it by the sample size, which is 15. So what do you get? You'll get 10.73. So is this a statistic or a parameter? This is a statistic. This is a statistic because it's a sample of 15 workers and not the population. What you have learned just now was the arithmetic mean, or the general type of mean if you want to find central tendency. Besides arithmetic mean, sometimes we may be interested to find the weighted mean or the geometric mean of our data set. What is weighted mean? Weighted mean is used when we find the same values appearing a few times in the same data set. So instead of, for instance, if we have 5 number 10s, so instead of adding 10 plus 10 plus 10 plus 10 plus 10, what we can do is we just take 5 times 10. So it works a lot faster. This is the formula for weighted mean. As you can see here, W refers to the weights, or how many times that particular number appears, and X here refers to all of our values in the data set. And we divide it with the number of weights. Okay. As for geometric mean, it's a very useful type of mean. We can use it in these two cases. First, if you're interested to find the average change of percentages, ratios, indexes, or growth over time, then we can use this geometric mean formula. Okay, now the difference is here. If you notice the x before, see, if you look at the arithmetic formula or the weighted mean, these x's here refer to values or number, whereas the x here, they are in percentages or ratios. Okay, so that's the main difference. So if you want to find the average of percentages, we use the geometric mean. Okay, let me just erase this for a while. Okay, now that's the first case when we want to use geometric mean. Secondly, if we want to find the average percent change over a period of time, again, we can also use the geometric mean. This time, this is how the formula looks like. See, we've got 2 time periods at the end and at the beginning. So we just divide the value at the end over the value at the start, find the root by the nth year, and minus 1. So you get the answer. Okay, so next we can try and do the examples. So we will have one example for each. one example for weighted mean, one example for geometric mean, the first case, and another example for geometric mean, the second case. But I think I will only be covering these two. So the example for this geometric mean, you have to attempt it on your own. This is an example of weighted mean. Let's read the question. The grade point average for college students is based on a weighted mean computation. For most colleges, the grades are given the following data values: A, 4 points, B, 3 points, C, 2 points, D, 1 point, and F, 0 point. After 60 credit hours of coursework, a student at State University earned 9 credit hours of A, 15 credit hours of B, 33 credit hours of C, and 3 credit hours of D. The first question is, compute the student's GPA. So as you can see, GPA is calculated using the weighted mean. So what must you do first? Identify how many A's or how many credit hours that got an A, how many credit hours that received a B, C, and so forth. So once you've identified that, it's basically here, this part, right? So now you can write it down in the formula. Okay, because the student earned 9 credit hours of A here, 15 credit hours of B, 33 credit hours of C, and 3 credit hours of D. Divide by the total weights. How you get that weight is basically 9 plus 15 plus 33 plus 3. Okay, so what you get? You'll get 2.5. So the student's GPA is 2.5. The next question. If the minimum requirement to be admitted into the business college is a 2.5 GPA for their first 60 credit hours of coursework, will the student be admitted? Yes, the student will be accepted because the student obtained a 2.5 GPA. Now, this is an example of geometric mean. The percent increase in sales for the last 4 years at Amira Busana Muslim Shop were 4.91%, 5.75%, 8.12%, and 21.6%. A. Calculate the geometric mean percent increase. B. Calculate the arithmetic mean percent increase. And C. Based on A and B, what is the relationship between the two? Now, if you remember, there were two formulas for geometric mean. Which one should you use in this case? I'll give you a chance to look back at your notes. In this case, we are finding the average percentages in 4 years. So we are going to use the first geometric mean formula. Okay. Now, all of these X in the formula refers to percentage increase. Okay. This is what information is given. We have percentages increase. So how do we write that down? What it means is, for instance, 4.91% is increase, meaning it is 4.91% on top of 100%. So how we write it down is 1.0491. Okay. As for 5.75, it's a percent increase, so we write it down as 1.0575. And 8.12, we write it down as 1.0812. And for 21.6% increase, we write it as 1.216. So let's say we have a percent fall. Let's say we have a percent decline by 10%. Okay, so 10%. Okay, or how do we write it down? 0.1. Oh gosh, this is harder than I thought. Okay, so how do you write it down in this formula? We write it down as 0.9. Okay, why 0.9? It's 1 minus 0.1. So basically, if it's an increase, we just add whatever number is given to you with 1. If it's a percent fall or decline, we minus it from 1. Okay, for more information, please read your textbook on page 66 to 67. I'm looking at the 17th edition of Lind, Marshall, and Wathen textbook. Okay, so now let's move on. Going back to this formula here. So as you can see, this is a product. Okay, so you need to multiply all of these number and then you find the fourth root. Why 4? Because they tell you the last 4 years. Okay, so what you get is this long number. You raise it to the fourth root, you will get 1.099. Now be careful, your answer, you can write it down as 1.099, but it doesn't mean it's 1.09%, okay? It simply means there is an increase by 9.9% on top of your existing 100%. So you can either write it this way, or in order not to get yourself confused, this is your final answer, 9.9%. So how to get that back is basically 1.099, you minus 1, so you'll get 0.099, which is actually 9.9%. Right. Now for B, calculate the arithmetic mean. Okay, so remember, arithmetic mean is simply adding all of these numbers and divided by 4 there. So it's quite straightforward. So you will get 10.1%. As you can see, the two figures, one calculated using geometric mean and one calculated using the arithmetic mean, they are slightly different. So which gives us the last question, based on A and B, what's the relationship between geometric mean and arithmetic mean? When they ask you questions about relationship, well, the safest bet would be to see which is higher, which is lower, or are there any difference between the two figures? So as you can see here, the arithmetic mean tends to be higher than the geometric mean. In other words, the geometric mean is always less than the arithmetic mean. Okay, so this is always the case. So that is why for finance, for instance, where figures are subject to compound effect, or when you have returns on investments, so it is always more advisable to use geometric mean when we want to calculate figures that concerns percentages or those that have compound effect. Right. Okay, so there, the geometric mean will always tend to be less than or equal to the arithmetic mean. Again, so if you want to study and read more about this, please refer to pages 66 and 67 of your textbook. You have already learned about mean. Now let's look at the remaining two measures of central tendency. They are the median and mode. What's a median? Median literally means middle. So the median is actually the middle value of a data set that has been rearranged from the smallest to the highest figure. Alternatively, you can also rearrange your data set from the highest to smallest number. So in other words, the median divides your data set into two equal parts. The median has the following characteristics. Now, just like the mean, the median is unique in that each data set has its own median. But unlike the mean that is sensitive to outliers, the median is not. So what that means is, even if you have extremely large values or extremely small values, the median will remain the same. Another difference with the mean is, remember I told you, mean can only be calculated for a data set that has at least interval level. Meaning, if you want to calculate the mean, you must make sure that your data set is at the interval or ratio level only. But for median, it can be computed for interval, ratio, as well as the ordinal level of measurement. Okay, so how do we interpret the median? Well, as I mentioned to you just now, the median divides the data set into two equal parts. So what you can say is 50% of the observation is greater than the median, and the remaining 50% is below or lesser than the median. So how do we want to find the median? Let's repeat. Number one, we rearrange your data set from the smallest to largest, or largest to smallest, up to you. And then we find what number sits right in the middle. So that's how you find it. Okay, now let's move on to mode. Mode is the most frequently occurring value. In other words, if you look at your data set, you look at the number or the value that occurs most frequently. So that is basically your mode. Okay, so the major characteristic of the mode is that it can only be found for nominal level data. And a data set that has more than one mode is possible. It's called bimodal. So how do we find the mode? Simple. You just look at your data set and see which number occurs most frequently. So you have already learned about mean, median, and mode. Let's look at this next example. Example 9 will test your understanding of the three measures of central tendency. A company's human resource department was interested in the average number of years that a person works before retiring. A sample of workers shared their remaining years of service as shown below. A. What is mode? What does it mean? B. What is arithmetic mean? Interpret its meaning. And C. What is the median? Explain this value. Okay, so now let's look at the data set given to you. From all of these figures, try to see which number occurs most frequently. Yes, you can see that number 24 appears 3 times, whereas all the other numbers appear only once or twice. So to answer A, what is the mode? Mode is 24. And what does it mean, or what does it signify? The most frequent number of years a person works before retiring is 24 years. Now, some students make the mistake of writing the mode as 3. Remember, 3 is not the mode. 3 is the frequency, as in how many times you see the number. So to answer what is mode, it must come from the data set. Now, let's look at the second question. What is arithmetic mean? First of all, is this a sample mean or a population mean? From the question you are shown here, you are given a sample of workers. Therefore, you must calculate the sample mean. So this is the formula for sample mean. So just add all of the values given to you and divide by the sample size, which is 11. So you will get 19.91. So the answer to B is 19.91. Now interpret its meaning. What does it say? The average number of years that a person works before retiring is about 20 years. Of course, you can answer as 19.91 years as well, but if you want to round it up, it's not a problem, but you have to put the word about in front of it, okay? Now let's look at the last question. What is the median? Okay, the first step to finding median is to rearrange your data set from the smallest to the largest value. In this case, it has already been done for you, so it's quite easy, right? So you just rearrange it. And now we want to find what number lies right in the middle. As you can see, number 21 lies right in the middle in your data set. Now, we are quite lucky in this sense because our data set consists of an odd number, which is 11. What if you're given an even number data set, like 10? So if you're given an even number data set, all you have to do is take the middle 2, let's say here. You take the middle 2 and then you divide it by 2. Okay, let's just erase this so that you won't get confused. Right, so now back to our question. What is the median? The median is 21. So how do you explain or how do you interpret the median? As I mentioned to you just now, since the median cuts our data set in half, the way to interpret is like this. Half, or 50% of the workers work less than 21 years before retiring, and the other half works more than 21 years before retiring. So you have already learned about mean, median, and mode. Now let's look at the relationship between the three. Once you understand the relationship between the three, you'll be able to understand and give comments on the basic shapes of distribution. Let's look at the first diagram. Okay, this diagram is called a symmetrical distribution. Symmetrical because all the three values of mean, median, mode are equal to each other. In other words, the symmetrical distribution shows the left-hand side is exactly equal to the right-hand side. Now let's look at the second diagram. Here you can see the tail is longer to the right. This distribution is called a skewed to the right or positively skewed distribution. Whereas this diagram, you can see the tail is longer to the left. So this is called a skewed to the left distribution or a negatively skewed distribution. Now sometimes it can get a bit confusing. How do you know if something is positively skewed or negatively skewed? So what you need to do is just to see. Look at the difference between the mean, median, and mode. Always begin with mode because mode means the value that occurs most frequently. In other words, when you look at the mode, you look at the frequency that occurs the highest. See here, mode is here. Now, the second thing you should be sketching is your median. Remember, median literally means middle. So median will always be in between the mode and mean. So that's why here we have the median. And finally, what's left is your mean. So this is the mean. So if you were to outline this, hence, you will get your positively skewed or skewed to the right distribution. How about the negatively skewed? Again, start with mode, because mode has the highest frequency here. So this is your mode, followed by the median, which is in the middle, and followed by the mean. So if you were to outline this distribution, see, you have the negatively skewed distribution. Now, example 10 tests your understanding of mean, median, and mode, as well as the shape of your distribution. Let's read the question. Below are starting admission price in ringgit for one-day tickets to 10 theme parks around the Klang Valley. A. Compute the mean, median, and mode. Interpret your answers. B. Based on the results in A, what conclusion can you reach about the distribution of the starting admission price for one-day tickets? Now let's start with finding the mean. Now, which mean would you like to use? Arithmetic mean, geometric mean, or weighted mean? So normally, if it's silent, then the usual calculation would be to find the arithmetic mean. Here. So what you need to do is just to add all of the data given to you and divide by the sample size. Now here I've assumed that this is the sample mean. Of course, you can also assume this to be the population mean if you assume that there are only 10 theme parks around the Klang Valley. Okay, so your answer here is 46.8. Now you're asked to interpret your answer as well. So how do you interpret this? 46.8. Remember, mean is the average value. So yes, you can say that the average starting admission price for one-day tickets of 10 theme parks around the Klang Valley is 46 ringgit and 80 cents. When you interpret, you must put the unit as well. Now, to find the median, remember, how do we find the median? First things first, you have to rearrange these data set from smallest to largest, or largest to smallest. Now, I hope you can pause this video and try to calculate or find the median on your own first. Okay, say you've already done it. So what's your median? Yes, your median is 42.5. Okay, so remember, how do you do that? You rearrange all of these numbers from smallest. What is smallest? The smallest is 29. Okay, and then followed by 40. Okay, and followed by another 40. Yes, I know this is absolutely horrendous, but just bear with me. Followed by 41, and then you have 42. Okay, where's my 42, and then you have 43, 50, we have 58. Okay, ideally you should write this on a straight line, okay, guys. 62 and 68. Okay, do we have 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good. Now, here we have an even numbered data set. So you don't have one middle value. You have actually two. So the middle values here are actually 42 and 43 here. So remember I told you just now what happens if you have an even numbered data set. You take the middle two value, you add them together, and then you find the average. So the average of 42 and 43 is 42.5. So that's how you got your median. So how do you interpret the median? Remember how to interpret median? Half of the starting admission price is below 42.50 and the other half is above 42.50. Okay, finally find the mode. Mode is quite simple. Here you can see that only 40 appears more than once. So yes, your mode is 40. Oh, sorry. I think I should erase this so you can see it clearly. Yeah, so mode here is 40. So how do we interpret that? The most frequent starting admission price is 40. So now you already have your mean, median, and mode. What conclusion? When they ask you about conclusion, basically they're asking you what's the shape of your distribution. Okay, so let's have a number line here. Right, so which is more? Okay, you can see mode. Okay, let's start with mode. Oh, okay, we have 40. Okay, this is, remember, this is your x. Okay, your x values. Okay, here would be your frequency, or y if you're learning math. Okay, so we have 40. Okay, that's the smallest value, because as you go to the right along your x, the number gets bigger and bigger. And then here is, okay, let's see, it's around here. This is 42.5. Okay, and then here we have 46.8. Okay, so you know that 40 is your mode because it occurs most frequently. Then here we have the median, then we have your mean. So what is this shape? Yes, it is skewed or slightly skewed to the right because the mean is slightly greater than the median and the median is more than the mode. Okay, so I hope you understand this bit. Okay, so we've already looked at the first part of describing data numerically, which is central tendency. Now, I mentioned to you that the second part, and more importantly, is not just enough to know where the center of your data set is. What is more important is to know the spread of your data. So this is where we learn the second part of describing data numerically, which is dispersion. Okay, so dispersion basically tells us how spread out our data set is from the center. Okay, so just like central tendency, we also have measures of dispersion. Now, there are also 3 measures of dispersion, which are range, variance, and standard deviation. Let's begin with range. Range is the simplest way to measure dispersion. What you need to do is simply find the largest value in your data set, you minus the smallest value. That gives you range. Okay, and because it's the easiest way to calculate, it also has 2 shortcomings. Number one, it is influenced by outliers. Just imagine if, because you're supposed to minus the largest value, okay, and you minus it with the smallest value. What if your largest value is an outlier and your smallest value is also an outlier? So it will give you a very huge range, and that may not be a good representation of your data set if every other value is close to each other. Get what I mean? So let's say these are all the other values, but then here's your smallest value, here's your biggest value. So it looks as if you have a very big range, where in fact most of your data set are right in the middle. So it might give a biased or an incorrect representation of your data. Okay, and secondly, another shortcoming is because it's only based on 2 values. So it may not be that sophisticated. It's not a sophisticated measure of dispersion. Right, so the second measure of dispersion is standard deviation. Now, this is a more popular and a more reliable, arguably the more reliable measure of dispersion. And of course, it's also the most used measure of dispersion. Basically, what standard deviation tells us is it tells us how close or how far apart each and every values that we have in our data set is from the mean. Okay, so let's sketch something here. Let's say this is your number line. Let's say this is your mean. Remember, mean is also meaning average or middle if they are symmetrical. Okay, let's say this is your mean, and let's say all of the other data values are here. Let's say they are around the mean, you know. Okay, let's say these are your other values. So if all of your other values are somehow concentrated or clustered around your mean, you can say that you have a relatively small standard deviation. Okay, so how do we sketch that? Maybe you can sketch it like this. Now, so this is how the shape looks like. It's more concentrated around your mean or your center. However, let's sketch another distribution. Let's say again, here, this is your mean. All right, but somehow the other values are spread out very far away from the center. Okay, let's do this. So how do we want to sketch this distribution? It's flatter, right, compared to the other. So in this case, if the values are widely dispersed or away from the center, you can see that your standard deviation is large. Okay, so I do hope you understand what standard deviation implies. If you had a problem, just go read the textbook, okay? Now, the standard deviation that we've learned just now, it's basically the square root. Okay, it's the positive square root of the variance. So if you understood what standard deviation was, you'll be able to understand what variance is. Okay, so here's the formal definition of variance. It is the mean of the squared deviations from the mean. And both the standard deviation and variance are both non-negative. So they cannot possibly be 0, because if it is 0, then all observations are the same. Okay, so the variance overcomes the weakness of the range by using all of the values in the population, which is correct. Now, you would only be able to appreciate this description if you look at the formula for variance. Okay, this is how to calculate variance. Okay, it depends if you're calculating population variance or sample variance. Okay, if you're calculating population variance, this is the symbol. It's called sigma square. Okay, if you're finding sample variance, you just call it S square or sample variance. Okay, now let's look at the first part up here. Okay, what you need to do first to find the variance, number one, you need to find the mean first. Now, if you're finding population variance, what you need to do is to find the population mean first. Once you find the mean, then secondly, you need to find the deviation. Deviation or difference. Difference what? The difference or the deviation between each and every value in your data set from the mean. Once you have that, you square those differences and add them together. Hence, this top part is normally called the sum of squares. Okay, sum of square difference. And then the third thing you need to do is to divide your numerator with your population size. Now, actually, if you have the lecture notes, you can actually look at the notes. I have specifically written down the step-by-step on how to get your variance and standard deviation and all that. So please refer to your lecture notes. Okay. Now, if you want to find the sample variance, it's similar. First things first, you need to find the mean. In this case, you need to find the sample mean first. And then you need to find the difference or the deviation between each and every value from the sample mean. And then you square it, and then you find the sum. Okay, up here again it's called the sum of square difference. And then you need to divide, oh I forgot to write the step 3. Okay, you need to divide it with your, in this case, sample size. Okay, here's the legend. Again, as I mentioned to you, you're supposed to listen to this video together with your lecture notes. So if you're having a hard time following through, just look at the pages that I'm talking about and you'll be able to see. Okay guys, this basically wraps up our second virtual lecture. I hope you would try example 11 and whichever other exercises that I did not cover in this video on your own. Please attempt them, because if you simply copy the answers in class, I tell you it will not help you to understand. So please take your time to try them. If you don't know how to do it, you can refer to the textbook, because literally the textbook specifies step by step on what to do. Okay, so you'll be able to do this. So I guess I'll see you in our next class. Bye. Assalamualaikum.